Today's lesson is 11.2, Prime and Composite Numbers. The objective is that I will learn to identify prime and composite numbers. The first problem we're looking at says Ian has 2 red tiles, 3 blue tiles, 4 yellow tiles, and 8 green tiles. He is making 4 rectangular placemats, 1 in each color. How many different mats can he make from each color? So we're going to take the information from this problem, and we are going to find the factors of each number. So 2, 3, 4, and 8. These are the numbers that we have from our original problem. I do want you to include this portion in your notes. The factors of each of our numbers. For the number 2, the only numbers that I can multiply together to get 2 are 1 and 2. For 3, the only numbers that I can multiply together to get 3 is 1 and 3. For 4, I can multiply 1 times 4 and 2 times 2, but if you remember when we list out the factors of each number, we only write each number once. For 8, I've got 1 times 8 and 2 times 4. Those are all the factors for each of those numbers. When we're talking about prime and composite numbers, we're going to think about the factors. So you have to remember your vocabulary from 11.1. Factors are the numbers that you actually multiply together to get another number. Include this vocabulary in your notes. A prime number is a number that only has 2 factors. The only 2 factors that a prime number has would be the number 1 and itself. So, for example, the number 2 is prime, because the only numbers that you can multiply together to get 2 are 1 times 2, so it would be prime. A composite number is a number that has more than 2 factors, so, for example, like we just looked at, the number 8 has 1 times 8. It also has 2 times 4, so it would be composite. The number 1 is neither prime nor composite. I do want you to include everything you see on this slide in your notes. It will help you later on. You will end up using your notes a lot when you're trying to remember the difference between prime and composite numbers. So we are going to take a look at this. Which of the following numbers are prime and which are composite? So I have the number 10, 11, 12, and 13. Be able to explain why. Well, I'm looking at the number 10. If I think about the factors of 10, sometimes you have to list out the actual factors in order to help yourself. But I have 10, so I think to myself 1 times 10, 2 times 5. There's nothing else that I can multiply together, but that was more than 2 factors, so that would mean that 10 would be composite. Include this sentence in your notes as well. Just because it is an odd number does not mean that it is a prime number. A lot of times people think that if a number is odd, it has to be prime, so there's not going to be another number that multiplies together, but that's not true. For right now, when I think about the number 11, the only numbers I can multiply together to get 11 is 1 times 11, and same thing with 13, so both 11 and 13 would be prime, but 12 would be 10 times 1, 12 would be 1 times 12, 2 times 6, and 3 times 4. Go ahead and include these in your notes as well. We are going to look at all of them, 1 through 6. Okay, we're looking at a little bit bigger numbers. And some tricks for thinking about prime and composite numbers is that typically all even numbers other than 2 are going to be composite, because all even numbers can be divided by 2, which would mean that one of their factors would need to be 2. 2, the only thing is 1 and 2, so that has to be prime. But looking at even numbers, you can automatically tell if a number is going to be prime or composite. If it's greater than 2 and it's even, then it's definitely going to be composite. This is going to be one of those times where you're going to really need to be working on your multiplication facts. So you automatically look at a number and remember, are there any other numbers other than 1 and that number that can multiply together to get that number? So looking at 32, well, I notice it's even, but if I needed to list out all my factors, I could. So I could do what we did before, and I could take the number 32, and I could list my factors, 1 and 32, 2 times, I might have to actually divide that out to figure out exactly how much that would be. Or you might already know that it will be 16, right? And then I look at 32. Does anything 3 go into 32? No. Does 4 go into 32? be 4 and 8. Well, does 5? No, it doesn't end in a 0 or a 5, and 6 doesn't either. So these would be all of my factors of 32, which again shows me that my number 32 would be composite. But when I look at the number 41, there's not any other numbers I can multiply together to get the number 41. So 41 would be a prime number. Okay, looking at 57. Well, I have to think to myself, is 57, is it divided by any other number other than itself, 1 and 1? So 57, 1 times 57. Is there any other numbers that can be multiplied together to get the number 57? Sometimes if I'm not sure if the number is prime or composite, I might have to actually double check. And so you might have to take 57 and divide it by, well, it's not even, so I know it can't be divided by 2. So I might go ahead and divide by 3 and see if that works. And I did, and it does, so I have that number as a composite number. Okay, I would like for you to complete 4, 5, and 6 in your notes. Remember, go ahead and guess and check to see if any numbers can be divided into it, because those would be factors.